Hi all, welcome to the second session of the third series of free training. Agenda for today's session is to understand application performance with APDEX course, monitor the code flow across applications via distributed tracing, pinpoint to the problematic elements in your application code, and visualize the dependencies in your application architecture with automated service maps. Here are some of the recent facts that we have gathered by our trusted sources like International Data Corporation and Forrester. According to International Data Corporation, 90% of the respondents are currently using the observability. This makes the management to have a deeper insight and to drill down the information of their application. The Forrester's research report states that 87% of engineers said that using cloud native architecture has increased the complexity of discovering and troubleshooting the incidents. Before discussing the topics in the agenda, let us start off with why an application performance monitoring is needed. Imagine a user is accessing an e-commerce website and trying to purchase from the online store. On completion of the selection of the items, they are attempting to place the order, and at the time of payment, portal page encounters issues like the portal taking a long time to load or getting redirected to a different page or showing some error codes, etc. So this could lead to losing of potential customers from accessing the application and leading to a loss of business. And for the developers who are working in this web application are unsure of the root cause. So in this scenario, the demand for using an application has increased, which has also led to the complexity in its development. Hence, it is necessary for the developers who are working in the application to make sure that the website is bug free and to handle the load in the application's database to ensure providing a better service to their users. Let us see some of the contemporary trends in application monitoring. The first is cloud native application. So recently, large enterprises have adapted to move many of their applications to cloud. The cloud native applications are scalable, flexible, and efficient software that uses small independent building blocks like microservices, containerization, which is commonly Docker, and Kubernetes. So the developers and the operation teams work closely together using the DevOps practices for faster and more reliable software delivery, such that monitoring these applications is essential, which helps in analyzing how each part of the application is working and to fix any issues for handling a lot of users. The second one is artificial intelligence for IT operations. So in this context of application performance monitoring, artificial intelligence and the machine learning in the recent times are used to enhance and to automate IT operations through anomaly detection for identifying unusual deviations, automate the IT task, predictive analysis for potential future using the historical data, and to optimize the resource allocation and scaling based on the real-time performance of the application. The third is user-centric monitoring. User-centric monitoring shifts the focus from system-centric metric to the actual end user's experience when interacting with any application. Users' experience is gauged by examining their journey from the moment they access the application to the completion of their task and identifying user centric metrics such as page load times, response times, and the overall responsiveness of the application, thereby helping to prioritize and improve the user satisfaction. The fourth is application observability. The application observability includes application performance monitoring, which helps in gaining insights into the performance, behavior, and also the health of an application, which is achieved through monitoring application transaction traces, their logs, execution time, and also identify the bottlenecks, errors, and inefficiencies in the code. The last is full stack performance monitoring. The goal of full stack performance monitoring is to identify and to address any performance issues across the entire application stack, like from the front end or user interface to the back end server infrastructure, by monitoring the various layers of the stack, including application code, server response times, and database queries. This by achieved by collecting the real-time data on various performance metrics like the response times and the error rates. So by adopting to these latest trends, which we have discussed, organizers can gain insights into the performance of their application in the real time, enabling them to proactively identify and resolve the performance issues before they impact the end users. So this is essential for maintaining the reliability, availability, and the responsiveness of the modern applications. These are some of the benefits of modern versus the traditional approach in building an application. Let us see one by one. So the first is application availability. In the traditional approach, applications were hosted on on-premises or single data center servers experiencing high downtime and limited availability, leading to potential performance issues during the high traffic periods. However, with leveraging the cloud computing and the containerization for better availability and utilizing the features like load balancing, redundancy, automatic failover, and global distribution has minimized the downtime by enabling continuous deployment without affecting the user experience. The next is cost reduction. So earlier, the scaling traditional application involved purchasing additional hardware and substantial investment in the infrastructure. High maintenance cost due to the need for physical hardware updates and repairs. With the cloud-based solution, reducing the upfront cost, allowing efficient resource utilization, horizontal scaling of resources based on the demand, automation and containerization contributed to operation cost saving. The third is global content delivery. Content delivery may be constrained to a specific location or data center where the users in different regions might experience latency and slower performance, that is, load times. Using the content delivery network and the edge computing will ensure faster and more reliable delivery globally. Cloud services has offered distributed content across multiple servers globally by reducing the latency for users worldwide. This improves the user experience and ensures consistency of performance worldwide. The last is operational efficiency. Managing and maintaining the traditional applications involve manual process for the deployment, scaling, and maintenance with limited flexibility and agility in responding to the changing business requirements. Through the DevOps practices such as infrastructure as code, continuous integration, continuous development pipelines, and container orchestration tools automate the process, enhancing the operational efficiency. The microservices architecture enhances the agility and the scalability for the evolving applications, and updates can be rolled out seamlessly without the downtime, and resources can be managed programmatically. So, in summary, adopting to a modern approach to building the application offers advantages such as improved availability, cost reduction, global content delivery, and operational efficiency compared to the traditional methods. The cloud computing, automation, and modern architecture principles are some of the key factors which contribute to the benefits, enabling business to stay competitive and responsive to the changing demands. So, the modern approach offers benefits such as improved scalability, which contribute to the higher availability compared to the traditional approaches. So, we have discussed why an application performance monitoring is necessary. In Applications Manager, the performance monitoring tool is called APM Insight. The APM Insight will give you an understanding the way your application is behaving for the end users who are accessing it. By a complete end-to-end transaction monitoring across your entire web application will help you to avoid any performance issues. Also, you can analyze the root cause of problems much faster by performing the first level troubleshooting. The supported technologies in APM Insight are Java, Node.js, .NET Core, Microsoft.NET, PHP, Ruby Rails, and Python. The factors that we have mentioned play a crucial role in determining the performance of an application. Let us explore each one. The first one is response time. When a transaction is made by an user in the web application, the request is sent from the application layer, which will travel through the transaction and the network layers and hits the application server, and this request is served back to the end user. The response time is the time taken for a transaction to be processed, which includes the time taken from initiating a request to receiving the final response. The query's response time is taken by the database queries to retrieve and return the data, or the speed at which the database queries are executed. Slow queries can significantly impact the overall application performance. The application performance is time taken by the application to respond to the input or request, which includes the processing time, network latency, and any other delays. The next is the application code. We know that bugs in the application code can lead to unexpected behavior, crashes, or performance degradation. Inefficient or excessive exception handling can impact the performance, and the frequent exceptions, which might indicate issues that need some attention. So, when an error occurs, a stack trace provides the information about the sequence of function calls leading up to the error. So, analyzing these stack traces will help in identifying the sources of performance issues. The next is memory. Monitoring the application's memory consumption is crucial. High memory usage can lead to performance issues and even some crashes. If the application exhausts its allocated memory, it might crash or become unresponsive. So, this occurs when a program doesn't release memory properly, leading to a gradual increase in the memory usage over the time. And the last one is database. Some of the database queries that can take too long to get executed can impact the entire application responsiveness. Optimizing these queries is essential, and the number of calls made to the database can impact the performance. So, reducing unnecessary or redundant database calls can improve the overall speed. Hence, monitoring and optimizing these factors is essential for maintaining the good application performance. Various monitoring solutions can help to identify and address the performance issues in each of these areas. Also, regular performance testing and tuning are essential for ensuring the application to run smoothly. Let us see the functioning of an APM Insight monitoring. The application performance monitoring is an tool that uses agent for monitoring the application. The initial step involves in deploying the agent onto the servers where your actual application are running. These agents are responsible for gathering the performance data and transmitting it to the applications manager for analysis. The agent within the application server utilizes a method called bytecode instrumentation to track the individual user transaction as they navigate through the application stack. It then sends this transaction data to the applications manager at a fixed time interval. This approach enables detailed monitoring of transaction performance, facilitating the identification of bottlenecks or performance issues. The tool offers code level visibility, allowing monitoring of slow database queries and their performance by capturing the real time user interaction with the application. Users can configure alerts and notifications based on predefined threshold for metrics that can impact the application performance. So when the application performance breaches these threshold, the tool will send an alert to the IT team. So this alert will aid the developers and also the IT team in pinpointing the areas that require improvement in performance, such as the application code, the database related issues, and page load times. So, this proactive approach will help to address issues promptly and also minimize the downtime. Exporting and elevating performance using the APM Insight data exporter. The data exporter, it is a standalone component or the module within the applications manager for collecting, processing, and sending the application metrics and traces for communication within the applications manager server. Its purpose is to export the data related to the application performance monitoring. The data exporter will operate as a separate independent process, which means it will run automatically from the other components or services within the applications manager. The primary function of the data exporter is to handle and to transmit information related to the application metrics and traces to the applications manager. The metrics will include various performance indicators such as response time, error traces, or resource usage, and the traces will typically refer to the detailed records of the execution flow of a transaction or the request within the application. A single instance of the applications manager data exporter is capable of managing the data processing for multiple applications. So this implies that the exporter is designed to handle the data export requirements for various applications simultaneously. So the exported data is sent to the applications manager, and the server will analyze this data and provide some insights into the performance and the behavior of the monitored application. Here is an overview of the data flow through the data exporter. The data exporter supports agents written in the Python and PHP. So these agents are responsible for monitoring the applications to capture their metrics and the traces. Developers or the IT team integrate the supported agents into their Python or the PHP applications. These agents collect the performance metrics, the traces, and the other relevant data from the application. A single data exporter instance is set up which will handle the data processing for multiple applications. It acts as an intermediary layer between the application and the application's manager server. The application will continuously generate the data related to its performance, like the traces and other metrics. This data is collected by the respective agents, that is Python or the PHP, which is running within the applications. So the data exporter processes the collected data to aggregate, filter, and format it appropriately for transmission. This step will involve organizing the data in a way that is compatible with the applications manager server's requirement. So once the data is processed, the data exporter will establish the communication within the applications manager server. It will send the aggregated data and the formatted data to the server for further analysis and storage. So the applications manager server will receive the transmitted data from the data exporter. It stores the data in a centralized repository and provides a user interface for monitoring and analyzing the performance, traces, and the metrics. The system administrators or the developers or the IT team can use this data to monitor the health, performance, and traces of the application, which will help them to identify the bottleneck, performance issues, and optimize the behavior of the application. Unfolding the advantages of data exporter. The first is improved performance, monitoring, and user satisfaction. So using the APDEX code will be more helpful in improving the customer satisfaction. Scalability, flexible deployment, and enhanced security. So using the enterprise tool, you can pre-analyze the data and enhance the security to reduce the network load from the application. Reduced network load, efficient communication, and customized data transmission, data-driven decision making. So you can alert your development team in prior and make your decision wisely before the application goes down, which can improve your application in efficiently communicating and provide the customized data transmission. These are some of the key performance indicators in an APM Insight monitoring. First is the APDEX score. The APDEX score, it is a numerical measure of user satisfaction with the performance of the application's response time. The second is response time. It measures the average time it takes for the application to respond to a user's request for the transaction across the application. The lower the response time are generally more desirable. The third is request. It is nothing but the counts of the total number of requests made to the application within a specific time frame and helps to decide the overall workload and usage of the application. Fourth is the data throughput. It indicates the amount of the data in bytes transferred or processed in and out in the network request by an application during the monitoring period. It helps in understanding the application's data handling capabilities. The last is exceptions. The exception will track the number of exception errors or failures that occurred during the cycle of transaction in a specific duration processing of request. So these exceptions could be of various types like errors such as server errors, timeouts, or the other issues that affect the application's normal operation. The first slide of understanding application performance with APDEX scores. These are the categories of application responsiveness. The first is satisfaction. This category represents the highest level of user experience where the application's response time is between the satisfied threshold and the excellent threshold. Users in this category are generally satisfied with the application's performance. The second one is tolerance. The tolerance category indicates that the application's response time is between the tolerating threshold and the satisfied threshold. So users in this category might tolerate the performance but may not be entirely satisfied as under the satisfied category. The last is frustration. This category represents the lowest level of user experience where the application's response time is below the tolerating threshold. So users in this category are likely to be frustrated within the application's performance as it does not meet their expectations. Tracking the application performance with the APDEX score. The Application Performance Index or the APDEX score, it is a standard metric to measure the user satisfaction with application response times. APDEX scale ranges from 0 to 1, where 1 being the best score representing the excellent user satisfaction. So the APDEX is calculated based on the total number of samples collected over the satisfied count added to the half of tolerating count. Advantages of monitoring the application performance using the APDEX score. The first is the user-centric performance measurement to understand the application behavior, which helps you to understand how the application performance directly impacts the user experience and enables you to prioritize the improvements. The second is easy interpretation of complex performance data with a common performance metric simplifies the complexity of the data into a single and easily understandable metric by providing a clear and standardized way to assess the application performance. The third is you can benchmark and compare the performance levels of different applications, allowing you to identify high performing applications, leading to consistent improvements across your IT environment. The fourth one is proactive issue identification and prioritization of code optimization. So when the performance falls below the acceptable levels, the APDEX score will help you to identify the critical transaction with low scores, highlighting the areas of the code optimization. Alerts are triggered by enabling quick issue identification and by improving the key transaction that impacts the user satisfaction. The last is the historical APDEX trend data will allow you to analyze the performance patterns over the time, helping in understanding the performance trends and identifying improving for ensuring a consistent positive user experience. So by now you would be more interested on configuring the key business transaction to monitor the entire performance of the application effectively. So in this slide, we shall see on configuring the key transaction of your business operation. There could be a high volume of activities made in the application. All the transaction would be captured, among which you can select the key transaction that you want to monitor in it and set a threshold based on the response time of the transaction. The second slide is monitor code flow across the application via distributed tracing. In a microservice architecture, it is necessary to monitor the transactions that are made between two or more applications or services. With the distributed tracing feature, you can track the transaction made between two or more applications. Let us understand how the tracking is done in the distributed tracing. When an API request is made by the application to another application, the APM inside will add an HTTP header containing the metadata required to track the request. If the APM inside is enabled in the other application, it will proceed the HTTP header and return the tracking information to its caller via response headers. If the other application in turn calls another service, the header propagation will continue and it traces all the paths that are taken by the original application across the distributed system. So using this data, we can monitor the start time, that is when the transaction was initiated, the response time, which is the time taken for the transaction to respond within the application, and the name of the transaction and the application. By clicking the expand tree view of the application name, you can view the method calls and the code blocks that has taken a significant amount of time to complete the request, and this will enable you to monitor the calls made between two applications and narrow down the problem. Auto scaling in APM Insight. So this auto scaling, it is an automated way of managing the resources for your application. Imagine you have an website where an application running on the cloud environment. Whenever the application automatically scales up due to high user interaction in the site, and to handle this extra traffic, a new instance will get added. However, when these applications are scaled down due to lesser user interaction, these newly added instances become unused but are still retained. So this leads to the license being consumed by the unused instances, resulting to new instances not being added for monitoring. Hence, with the help of autoscale mode in APM Insight, you can overcome this scenario by automatically unmanaging or deleting the unused instances in the cloud environment. Pinpoint to the problematic elements in your application code. Here let us see the need to eliminate the issues in the problematic code. As you're aware, stack trace represents the movement of an application during the execution of a program. When Java application throws an exception, the stack trace gets logged within it. By analyzing the stack trace provided by APM Insight, the developers can pinpoint the exact line of the code and the sequence of function leading to the issue. This information will help them understand the root cause of the problem and can make the code optimization or the bug fixes to eliminate the issue and improve the application performance. With the stack trace, the developers can efficiently troubleshoot and resolve the problem within the application's code, ensuring a smoother and more reliable user experience. Gaining deeper visibility into the Java based application performance using the context based monitoring. So you can enable context based monitoring for your Java application. This will allow the need to track and trace the individual user transaction, capturing the data on how each registration transaction flows through your application server. Let us say your application server has 3 Java applications running on it. By default, the transactions of all the applications coming from the same app server are shown collectively under the web transactions in the APM Insight. In the image, as you can see, Tomcat application is the application monitor name and Jetpet store sample and sample web page are 3 contexts that are running on the same application server. The transactions of these 3 Java apps are listed out in the Web Transaction tab. Now, with the context-based monitoring, you can monitor the performance of all individual applications running in the same app server separately. This will help you to analyze your application performance. This means that by enabling the context-based monitoring, the transactions of JPEG store, the sample web app, and sample can be viewed separately. The last slide, visualize the dependencies in your application architecture with automated service maps. So what is a service map? So it is nothing but which will provide you a complete overview of the application infrastructure with the connection to the other dependent resources. So the purpose of a service map is to easily identify the status of the application and the instances, monitor the key metrics like the response time, throughput, and status of the connection, detect and troubleshoot your application problems before your customers are getting impacted, and monitor the number of failed request count. There are 3 types of service map. One is the map view, table view, and graph view. So here under the map view, it will provide you the way of analyzing the topology view of the application along with its instances which are represented in the central node. Now let us look on how all these can be achieved in the APM Insight Monitor and discuss on generating the reports and configuring the alarms for the performance metrics. So this is the overview of an application performance monitoring. As we have already seen, these are some of the key performance indicators of the APM Insight Monitor. So this summary tab will provide you the summary of the response time broken by their components like the web and background. transaction list, the exception count, the request throughput, and the data throughput. You will be able to monitor or get the top 5 transactions by their response time and the top 5 slow traces and the recent 5 transactions that has occurred during the last 30 minutes. So if you're looking for a longer time period, you can customize the time period by choosing them from this option. So recently in the latest Applications Manager, we have enhanced this particular feature. And for .NET and Java based monitoring, we have enhanced the or automated the installation of Java agent. That is, for instance, if I'm trying to monitor or sorry, if I'm trying to add any Java based monitor, we have bought 2 options. That is, you can either use the automated option or we have an option to switch to manual steps. So the manual steps, it will include you to download the agent, then copy the APM inside the license key and add the application manager's port number and the details and then configure. But through the automation steps, we have made this deployment more simpler. That is, through the UI itself, you can perform them. So here you will be able to choose between host or container through which you want to add the APM Insight Monitor. If I'm choosing between the operating system for Windows, and if I go next, I would be able to provide the application name and the application's running port and choose the Java version. And also from here, we'll have to check for the supported platforms. So on the right hand side, you'll have to check which are the application servers that has been supported and their frameworks and the databases and some of the components. So once these are all uh, some of the prerequisites, when these are completed, you will be able to add the APM Insight Monitor automatically. So here we have a command which you'll have to directly copy from here and run it on your application running server. So this will ensure that the APM Insight monitoring is automatically added without performing any manual steps like by downloading the agent and running the agent. As I have mentioned, we have this option currently only for Java and for .NET based monitoring. For the others, we are on a process of performing the same thing. So once the monitor is added, so you would be able to see its the key performance indicators in the monitor page. So let us see one by one. Here under the transactions, we have 2 views. One is the table view and the other one is the graph view. So under the table view, for the last 30 minutes, you will be able to see what are all the data that has been collected based on the user interaction with the application. So if I'm choosing for the last 7 days, it will show me the APDEX score, that is the user satisfaction metric, the response time, the request, and the data throughput. When I click on the individual transaction, it will show me the latest recent transaction and also the slowest traces within the particular transaction. So for an in-depth details of how the a particular transaction has been working, I can click on the traces. So this will show me the number of method calls that was involved in this particular transaction. As you can see here, there were 27 method calls with 360 SQL statements running in the backend. So when I move on to see what are all the SQL statements, I will be able to find the time taken for the queries that has been running for the particular transaction, the total time it has taken, and what was the query. So the trace details will further let me know for the each and every method that has been running for this particular transaction over here. So for the individual transaction, if I want to monitor their JVM, I will be able to get that details as well over here. So like you will be able to monitor the JVM's CPU usage, the classes count of the JVM, heap memory and non-heap memory. So this is available for each and every transaction that you monitor. Separately, under the database tab, you have an option to see all the database operations that were performed. So you will be able to monitor their total request, the errors, the response time, and the average response time. So further, when I go into a particular query, I will be able to know which particular transaction was being used for this database operation, the top 10 transaction of this database operation by the response time, and based on the throughput, I will be able to monitor here. And through the traces tab, all the traces that are collected for the last 7 days will be available. So each and every data, when you want to export it, we have an option here to do it through the export as Excel, PDF, or the CSV file format, only for the table view. But when it comes to the graph view, you have an option to take a complete screenshot of the full page. So by sending this particular data to the development team or the database, the IT team, they would be able to troubleshoot the issue in the application. So only for a Java-based application, you will be able to find the JVM, where, as you can know, these are some of the performance indicators of the JVM, like the CPU usage and the JIT time, the runtime memory. So here under the exceptions, for the last 7 days, you will be able to find what were all the top exceptions that has occurred when a user transaction was made. Some of the error codes, that is the top error codes, the exception split up can be monitored. So when I go into a particular exception, I would be able to see the exception count and the recent 5 traces for that particular exception. So this will again take me back to the traces tab, which will provide me the details of how the uh, exception was happened for that particular transaction. So here, if I want to know the specific class in which the exception has occurred, you will be able to get the whole stack trace of it from here. Also, recently in the latest builds of the applications manager, we have also enhanced and integrated the RUM analytics with the APM Insight Monitor. So this will provide you the front end of a behavior of the application. So here you will be able to map your RUM monitor with that specific application which is being monitored. So this is the first phase of API, monitoring that we have integrated. And for a detailed notes of how the RUM analytics is working, you will be able to go into that monitor and you can get the details like their ISP, the browser, the user sessions. However, in the APM Insight, we have provided only some of the basic or some of the summarized data which are required for the real user monitoring, like the page views, the error count for that particular application. So here from the monitor actions, you will be able to configure the alarms. So for the availability and history, health of the APM Insight Monitor, And for some of the key metrics like the response time, the APDEX, and the satisfied metrics, frustrated metrics, tolerating metric, and these are some of the other performance metric for which you would be able to configure the alarm. So once the threshold is getting breached for these metrics, the health of this APM and site will be affected. And if any email action or any other actions are configured for it, the alert can be sent to the particular emails or the uh, other actions. So this brings us to the end of the training session. So let us have a quick recap of what we have discussed. Tracking the application performance using the APDEX code, finding the problems in the application code, tracking the transactions from one application to another and debugging their issues, identify the problem in a code stack, and how the service map makes it easier to identify the problems. Thank you for showing your interest in attending the webinar. Thank you.